Hello ladies and gentlemen, welcome to Declarative Amsterdam 2020. My name is Charaf Eddine Cheraa and I will be talking to you today about Petal, an in-browser editor for LwDITA. First, allow me to introduce myself. My name is Charaf Eddine Cheraa. I'm currently an engineer at Evolved Binary. I have been working as a web developer since 2009 using different front-end and back-end technologies. I also develop in whatever language I find interesting. I have been doing that since 2007. I am contributing to Fusion Studio. I love all programming and spoken languages and I want to learn as many as I can. First, let's look at the state of in-browser XML editors. We know that with the rise of HTML5, we can find numerous open source JavaScript components for simple in-browser editors like Quill and TinyMCE that produce documents in a subset of HTML5. Likewise, there are free and commercial software as a service offerings that edit and publish restructured text or Markdown documents from within the browser, such as readthedocs.org and Gitbook. On the other hand, we can see the slow demise of XHTML. Simple in-browser WYSIWYG editors for producing XML documents have all but disappeared. Even the commercial offerings are too complex compared to the HTML5 editors we have. And that is likely driven by several factors. The complexity of offering a full XML editor. One of the advantages of XML, as we know, is its flexibility. An author can arbitrarily decide on their document structure and element and attribute names. However, this adds complexity to any such editor. Conversely, schema languages for XML that limit that flexibility by enforcing a certain document grammar require extra parsing and validation steps by the editor. Another factor is the decrease in XML processing support within the browser itself, and the perceived reduction in what constitutes an acceptable level of reuse and presentation for technical documentation. When compared to HTML5, Markdown, and restructured text, we believe that there are still key advantages that can be exploited by using XML for technical documentation. For the purposes of authoring and publishing the documentation for our FusionDB server, we examined several markup formats. DITA was one of them. DITA, which stands for Document Information Typing Architecture, or Darwin Information Typing Architecture, is an XML data model for authoring and publishing. It is an open standard that is defined and maintained by the WYSIWYG Technical Committee. It is what we want, but it's too complex for our needs, if only it didn't have more than 600 different elements. That's why we settled on lightweight DITA, which is a simplified version of DITA. It has a smaller element and attribute set, 48 elements to be precise, without sacrificing the practicality we want to achieve. It also has a stricter content models and a reduced feature set. LwDITA also defines mappings between XML, HTML5, and Markdown, enabling authoring collaboration and publishing across different markup languages. It uses XML format called XDITA, HTML format called HDITA, markup format called MDITA. And on top of that, we wanted to add a new authoring format, a JSON format called JDITA. JDITA is a JSON representation of an LwDITA document. Its main purpose is to make it easy to process and generate LwDITA content using modern web technologies, providing LwDITA capabilities to a wider range of users, mostly web developers. And with the help of JDITA, we can make Petal, our in-browser editor for LwDITA. So, what is Petal? It is a WYSIWYG editor aiming to make use of JDITA and Browse Mirror to create and edit LwDITA documents on the web. This project is divided into two packages. The first, JDITA, which parses XDITA documents from XML and produces JDITA documents, JSON, and vice versa. The second, Browse Mirror JDITA, which creates browse mirror documents from JData and sets up an editor to edit the contents on the web page. So, how do these two packages work together? The first package, JData, its main job is to generate JData documents from XData. To achieve that, the XData document is parsed, a set of JData objects is created, starting with the document node object, then a subtree of the rest of the nodes. Each node, when created, expects a predefined set of attributes, as well as an acceptable set of child nodes, thus validating the XData document while creating the JData one. By default, the process fails on the first error. However, there is an option to ignore errors and continue. This can fix minor problems like forgetting to close tag or having an extra attribute. Each JData object can generate its own JData representation, which includes the JData representation of its whole subtree. So, by generating the document nodes JData, you will get a JData representation of the whole document, and that's the package's main job. Alternatively, the package can also reverse the operation. It will read a JData document, creates a set of JData objects from it, and then serialize them into an XData document. As for the second package, browse mirror JData, it allows editing JData documents. How? It generates a browse mirror schema, which describes the set of elements that make the document, along with the relations between them, as well as how to display them on the page, which we try to make it conform to HData standards. It also generates the document itself from a JData document into a browse mirror document, a format that browse mirror can understand. It provides a set of commands for editing the document, inserting new elements, and transforming content. And it creates back a JData document from the browse mirror document that's being edited in the editor. And how are we going to put all of these together? That's what Petal is for, our editor. Petal takes a browse mirror document, casts it on our schema, and populates the result into a beautiful HTML document inside an editor. You can edit the content, but you can't, for example, delete an item that you shouldn't be able to. Why? Because the editor strictly adheres to the schema. Even though the schema plays an important role in the editing experience, it's not everything. We also need to implement LwDITA related commands, mostly for inserting new elements. There's also the option to edit elements attributes. Some of these attributes can reflect on the looks of the item itself, like an image source attribute or a cross-reference. And now to the interesting part, the demo. This is the XData document that we are going to use. Pass it to JData package, and you get a neat JData document. This JData document is what Petal uses to create this nice looking editor. Notice how the document as we see it is in HTML5, and we can start editing right away. As you can see here, we can edit text directly as you would do on any text editor. We can add paragraphs simply by pressing enter, also that's expected. We can add bullet lists. Notice that pressing enter here gives me a new paragraph, as expected. But what if I want a new list item instead? Press enter again, that's all. We can add numbered lists too. We can nest elements. We can add images. They are inline, so we can simply use backspace to delete them. We can style our text using the toolbar or keyboard shortcuts. And of course, undo and redo. It's not an editor without them. We have here Debug Mode. We can use it to see the actual LwDITA structure of the document. Look how we got here a paragraph, then a new list item. Look here, how it can split paragraphs. And how it can be smart enough to split elements across paragraphs too. And also join two paragraphs elements into one. That's all for the demo, but it's still rough around the edges and far from complete. We still have many more features to work on, but the goal is always to make it an essential tool for authoring technical documentation. Thank you for your attention. You can access this presentation on the link. You can also try the demo for yourself. Your feedback is much appreciated. Thank you again, and you are welcome to ask any questions you like.